Hello, this is Professor Santiago, and today we're going to talk about real numbers and their properties, one of many videos. If you have questions on this and other videos, please contact me at John at e-liteworks.com or visit my website at freedomuniversity.tv where you can find this and other videos as well. Now let's do a little bit of definitions when we try to classify numbers. A little bit of review. First of all, the set is a collection of objects called the members or elements of the set. And this is denoted by these curly brackets, and you list the elements. Based on this definition, let's take a look at the set of natural numbers, which basically are counting numbers from 1, 2, 3, and so on. The set of three dots basically is called the ellipsis, where it just means a continuation of the pattern shown here. The set of whole numbers is just adding the 0 to the set of counting numbers. And then the set of integers includes negative numbers and positive numbers and the number 0. Another way of looking at this set of classifications is through Venn diagrams, in which we want to look at the set of real numbers. Again, we'll start off with the natural numbers, which are counting numbers, and that's basically a subset of a bigger set called the whole numbers. More general than the whole numbers, as we saw, are the integers, which goes again from negative numbers to positive numbers. And then finally we have rational numbers, because based on these we can generate fractions, decimal points, and here we have a decimal point with repeated digits right here. So that's the rational numbers, in which we can express rational numbers in terms of a fraction, where we have the numerator as an integer and the denominator as an integer. So we can represent a rational number in terms of a fraction. On the other hand, there are some numbers that cannot be represented as a fraction. For example, the square root of 2 and the value of pi, which is denoted as 3.14159, which can go up to, non-repeated, up to 1,000,000 places. So these numbers, these irrational numbers, cannot be represented as a fraction. Now let's once again take a look at rational numbers. As mentioned before, rational numbers are a set of numbers consisting of all numbers that can be written as quotients, where a and b are integers. Or in other words, it's a decimal number that terminates or repeats. So we have a ratio of numbers, or a fraction, where b is not equal to 0. On the other hand, irrational numbers, the set of irrational numbers consists of all real numbers that cannot be written as a quotient of two integers, decimal number, and never terminates and never repeats. Once again, irrational numbers is a decimal number that never terminates and never repeats. We saw that with square root of 2 and pi. Let's look at some more examples. Again, using this chart shown earlier, negative 3 is an integer, rational number, and a real number. 0 is a whole number, integer, rational number, and a real number. Square root of 5 is an irrational number because it cannot be represented by a fraction. 0.3 is a rational number and a real number. Point 10, 100, and 100 is an irrational number because it never terminates. On the other hand, this terminates, and therefore this is a rational number and a real number. If you have questions on this video, please contact me at John at e-liteworks.com or John at eliteworks.com, or visit freedomuniversity.tv if you'd like to see more examples of this type of topic in algebra. or other videos as well.